Okay, I want to start today's deep dive with a bit of a provocation, a bold claim that might actually make you look at your driveway a little
Well,
differently.
like where this is going.
Imagine this. You go out, you buy a brand new luxury car. We're talking six figures. It's got the Napa leather, the massive 4K screens, the ambient lighting, all the marketing buzzwords like magic body control.
The works.
Right. But what if I told you that beneath all that gloss, beneath the software and the branding, you were basically driving a Victorian horse-drawn carriage?
It sounds like hyperbole, doesn't it? But if we look at the mechanical engineering, specifically how the car connects to the road, it is technically true.
And that is the whole premise of the source material we are unpacking today. We're looking at a breakdown from the channel Drive at RPM titled Physics Broken, released this year, 2026.
And its central thesis is that we have been sold, well, a lie for exactly 140 years.
A 140-year lie. The argument is that since the very first internal combustion engines rolled out of sheds in Germany in the 1880s, the fundamental interface, the suspension, hasn't really changed.
We are still using a passive system. It's a fascinating look at technological stagnation.
And just to be clear, we aren't just talking about shock absorbers today, are we? This isn't just a deep dive for mechanics.
No, absolutely not. We are talking about a fundamental shift in physics. We're talking about the end of the compromise between comfort and handling that we've all just, accepted as a fact of life.
And if we zoom out, it's a massive geopolitical wake-up call for the entire auto industry.
It really is.
Plus, we're going to talk about cars that can literally jump, drive on three wheels, and float on water. So there's that.
That is the, let's say, insane part of the equation, yes. But we have to eat our vegetables before we get to the dessert. We have to understand why the current tech is broken.
Okay, so let's unpack this 140-year lie. Because I think most people assume suspension has gotten super high-tech. I mean, my car has a sport mode button. I press it, it gets stiff. Isn't that high-tech?
It has a button, yes. But mechanically, it's likely still a steel spring and a tube of oil. That's the status quo.
A spring and a tube of oil.
You have a spring to hold the car's weight and a damper that oil-filled tube to stop it from bouncing forever. When you hit that button, all you're doing is slightly closing a valve to make the oil flow slower. I mean, it's crude.
Okay, crude, but it works, right? I'm not bouncing off the road.
It keeps you on the road, yes.
Right.
But here's the problem, and the source identifies it as a physics failure called hysteresis.
Hysteresis. Okay, sounds like a medical condition. Break that down for me. No PhD required.
For sure. Think about it like this. Imagine you are standing in a swimming pool, chest deep in water.
Okay.
Now, try to punch your hand through the water as fast as you can. You feel that heavy resistance, that drag.
Oh, yeah, absolutely. It fights back. It's like hitting a wall for a split second.
Exactly. That is hysteresis. A shock absorber is filled with oil. When your tire hits a sharp bump bang, that oil inside the tube is still trying to wake up. It has viscosity. It takes time to move.
So for those first few critical milliseconds.
For those first few milliseconds, your suspension isn't a cushion. It's a solid brick. It literally cannot move fast enough to absorb the initial impact because the physics of the fluid won't allow it.
So the impact goes straight into the chassis and straight into my spine because the oil hasn't realized it needs to move yet.
Precisely, it's latency. Yeah. And for a century, engineers have effectively gaslighted us. They told us this lag was unavoidable. They said, you have to choose. You can have a soft ride like a hovercraft or sharp handling like an F1 car, but you can't have both.
They said it was an immutable law of physics. Sorry, you can't have it all.
And the source argues that they lied, or at least they stopped trying to solve it, because the solution was actually identified decades ago.
This is the part that surprised me. I had no idea we had this tech in the 90s. I thought the 90s were just about CD players and beige interiors.
We absolutely did. This is the road not taken. There are two key players here. First, the Williams Formula One team in the early 90s. They built the FW14B car with a fully active hydraulic suspension. It was so dominant.
And naturally, because it was too good, the fun police stepped in.
The FIA banned it, yes, said it was a driver aid. But then you have the story of Dr. Amar Bose.
The speaker guy. The noise-canceling headphone guy.
The genius behind Bose audio, yes. He was obsessed with this problem. Oh. He spent 30 years and hundreds of millions of his own dollars proving that you could replace those oil dampers with electromagnetic motors.
I've seen the old footage of his prototype. It's this old Lexus from the 90s, and it literally hops over a plank of wood like a rabbit. It looks like CGI.
It was very real. He solved the hysteresis problem. He proved you could have a magic carpet ride.
So, why aren't we driving Bose cars? If it was that good, why are we still on springs and oil?
It wasn't hate for innovation, it was energy. The industry in Detroit and Germany looked at it and said, it's heavy, it's complex, and it eats power. You have to remember, combustion cars run on a 12-volt electrical system.
Just the little battery under the hood?
Right. Trying to run an active electromagnetic suspension on 12 volts is like trying to fill an Olympic swimming pool with a drinking straw. You just cannot move the energy fast enough.
You need a fire hose.
You need a fire hose. So the industry shrugged, said, nice try, Dr. Bose, and went back to polishing their hydraulic valves. They bet the internal combustion engine would rule forever.
And that was their fatal mistake.
They failed to predict the rise of the high-voltage EV platform.
Which brings us to today. The source material pivots here to a company I think a lot of listeners might still underestimate, or, maybe just know as that Chinese EV brand, BYD.
BYD is fascinating because they didn't start as a car company. They started as a battery company. And the source argues that while Western engineering stalled, BYD picked up the baton that Dr. Bose dropped.
Because they had the fire hose.
Exactly. The rise of the EV provided the missing piece. Huge energy sources. We're talking 800-volt architectures. This allowed BYD to create what they called the DiSus-Z system.
Okay, DiSus. Let's get technical, but keep it simple. The source calls this a dry system. What does that mean?
It means if you slice it open, nothing leaks out. No oil, no gas, no hydraulics.
So what's inside?
Magnets and copper coils. Imagine a high-speed maglev train, the kind that floats, but wrapped into a compact cylinder inside the car's wheel arch.
So instead of a spring squishing oil, you have magnets pushing against magnets.
Effectively, yes. It's a three-phase linear electromagnetic motor. And because it's using electricity and magnets, it generates force at, well, nearly the speed of light. It doesn't have to wait for oil to flow.
The source threw out a number here that just blew my mind. 10 milliseconds.
That is the critical number. That is the system's reaction time.
Let's put that in context. A human blink.
A blink is about 100 milliseconds. Your brain takes 200 to 250 milliseconds just to process a visual threat.
So the car is adjusting the suspension 20 times faster than I can even realize I hit a bump.
Faster than you can perceive the bump even exists. The car uses LiDAR and sensors to read the road ahead, and the motors physically move the wheel out of the way before the bump gets to the cabin.
It's predictive.
It makes something called skyhook theory possible in the real world.
Skyhook. I love that term. Paint the picture for me.
It's the holy grail. Imagine the body of the car is suspended from a hook in the sky. It stays perfectly level with the horizon, totally fixed. Meanwhile, underneath, the wheels are just articulating furiously, extending into potholes and retracting over bumps.
So the wheels do all the manic work, and the cabin is just floating.
It effectively erases the road.
Okay, hold on. The energy thing. You said we needed a fire hose of power. If I'm driving down a bumpy road and these motors are working like crazy, isn't that going to kill my battery range?
That is the most common question, and the answer is actually the opposite. This is where we get into thermodynamics.
Regenerative damping.
Correct. Your old oil damper takes kinetic energy from a bump and turns it into heat. The oil gets hot. That energy is just wasted.
It just throws it away into the atmosphere.
But the DiSus system uses magnets moving through coils. That's the exact same physical principle as an electric generator or a wind turbine.
Oh, wow. So every bump is generating electricity.
Yes. Every time the wheel moves, it induces a current. So on a rough road, the suspension is actively harvesting energy and feeding it back into the battery.
So worse the road is, the more energy I get back.
In theory, yes. It turns bad infrastructure into electric range. It closes the energy loop that killed the original Bose project.
It makes the car symbiotic with the road.
That's fair.
That's deeply cool.
Yeah.
But I have to play devil's advocate here.
Yeah.
What about unsprung mass?
The old engineer's headache.
Right. The idea that you want wheels to be as light as possible. If you bolt a heavy electric motor to the wheel, doesn't that make the handling terrible? Like running in lead boots?
That is absolutely true for a passive system. A heavy wheel and a dumb spring is a disaster. But the DiSus-Z is active. The motor manages its own mass.
How can it manage its own mass? Heavy is heavy.
It manages the movement of that mass. Think about gravity. Gravity pulls things down at 9.8 meters per second squared. That's the speed limit for how fast a tire can naturally drop into a pothole.
Okay.
These linear motors can accelerate the wheel downwards faster than gravity.
Wait, what? Faster than gravity?
Much faster. It forces the tire into the tarmac. It generates mechanical grip where none existed before. It turns the suspension from a shock absorber into a downforce generator. The weight doesn't matter because the motor is overpowering the physics of weight.
It's literally grabbing the road.
That's the one.
Okay, so that's the civilian version.
Mhm.
We have to talk about the weaponized version on the Yangwang U9 supercar, the DiSus-Z.
The X for extreme, I guess. This is where the physics gets really intense.
The power output alone, 36 kilowatts just for the suspension.
Think about that. 36 kilowatts is more power than the entire engine of some small city cars. And that's just to move the suspension.
And that allows for the party trick that went viral,
Yeah.
the jumping car.
Right. You've seen the video. The U9 crouches and then literally leaps all four wheels off the ground.
Okay, I have to stop you there. A jumping car. It sounds great for TikTok, but does it actually matter? Is this just a billionaire's toy?
It does sound ridiculous, I grant you. And yes, jumping in a parking lot is just showing off. But the jump isn't the point. It's the proof of the point.
Proof of what?
Proof of power density. If you have enough explosive power to lift a 2.5-ton vehicle into the air, you have enough power to do things that actually save lives. The revolution is the three-wheel drive scenario.
Okay, explain that.
Imagine you're in a traditional supercar at 120 miles per hour and a wheel disintegrates. A blowout, a hub failure, or whatever.
I mean, that's usually game over. The corner drops, the chassis hits the asphalt, sparks fly, you spin out. It's a catastrophe.
Exactly. You're a passenger to physics. But with DiSus-Z, the sensors detect the pressure loss. The system instantly retracts the hub of the missing wheel up. It lifts the broken corner clean of the ground.
Dog holding up a hurt paw.
Exactly like that. It balances the car on three wheels. Then it stiffens the opposite corner as a fulcrum and uses the electric motors to torque vector the remaining wheels to drive the car straight.
So it turns a fatal crash into just a manageable event.
You can pull over safely. The source compares this to, say, the Porsche Panamera's 48-volt anti-roll system. It's good. It can twist a bar to stop the car from leaning, but it can't lift the car. It can't drive on three wheels.
The source calls the 48-volt system a toy compared to this 800-volt sledgehammer.
It's a brutal comparison, but it's accurate.
Speaking of sledgehammers, we have to talk about the U8, the massive SUV. It uses a different system again, DiSus-Z.
Right. P for pressure. This is intelligent hydraulics, but not the Victorian kind.
Yeah. This one seems like it was built for the apocalypse.
It allows for concurrent three-axis control, no mechanical sway bars. On the road, it stiffens by 200% so the SUV doesn't wallow like a boat. But off-road, it opens up to allow huge articulation.
And it have these survival engineering features that are straight out of a spy movie, like the emergency float mode.
This is incredible. If the car enters deep water, it senses it, seals the body, raises the suspension to the max, and then spins the wheels to propel the car like a boat.
And the tank turn.
Only possible because the suspension can stabilize the chassis while the wheels spin in opposite directions to rotate the car on its own axis.
And my favorite, the dog trick.
It's quite a visual. If you get a flat tire and you don't have a jack, the suspension can lift the damaged leg high enough for you to change the tire. It lifts itself.
It's the ultimate redundancy. It's not just luxury, it's survival.
It really redefines what an off-roader can do.
So I want to zoom out. We've talked about the tech, the magnets, the jumping, but there is a cultural shift here that the source talks about that's, well, it's the death of the tuning guru.
The guy in the white lab coat at the Nürburgring.
Yeah, that guy. The romantic idea of the German engineer.
It's a tragedy for the purists. For 50 years, the secret sauce for BMW or Porsche was a guy named Hans testing physical springs, swapping out metal shims. That was the soul of the car. It was an art.
Mechanical alchemy.
And DiSus-Z just killed the artist. Because now, you don't need Hans. You need a coder in Shenzhen who can adjust a variable from 0.5 to 0.8 and upload it to the cloud.
The feeling of a Porsche is now just a file you download.
The hardware is identical, but you can download a personality. You want a GT3 track car? Download it. You want the float of a 1970s Cadillac? Download it.
Over-the-air updates for your suspension. Today, I feel like driving a Ferrari. Tomorrow, a Rolls-Royce.
The soul of the machine has migrated from metal to silicon, and it allows BYD to iterate the handling every month based on user data. A mechanical suspension is set in stone. This car learns.
This brings us to the hard truth, the geopolitical slap in the face.
The source material is very blunt about this. It argues that the era of mechanical excellence, the era that Germany dominated, is over. We are now in the era of the software-defined vehicle.
I think the perception in the West is still that China just makes copies, or cheap alternatives. There's still this arrogance that German engineering is the peak.
A very dangerous misconception. The source states clearly, BYD hasn't just caught up. They have innovated a technology that renders European chassis engineering obsolete.
There's that quote. BYD has brought a nuclear weapon to a knife fight, and the legacy manufacturers don't even realize they are dead yet.
It's harsh, but when you look at the physics, the difference between a 10-millisecond active reaction and a passive oil damper, it's hard to argue with.
It really reframes the whole value proposition for the consumer.
It does. The question is no longer, is a Chinese car good enough? The question becomes, why am I paying $100,000 for a German car with Victorian technology?
Why pay for the horse-drawn carriage when you can have the maglev train?
Exactly. The road didn't get smoother. The machine just finally learned to conquer it.
So what does this all mean? It feels like we are witnessing a silent revolution.
It is silent, it is electric, and it is terrifyingly fast. The things we valued, mechanical complexity, tuning heritage, are being replaced by power density and software.
It's a lot to process. I think I'm going to look at every pothole differently now, knowing that my car is just dealing with it the old-fashioned way.
Lagging behind.
Literally.
Yeah.
I want to leave you, the listener, with a thought. If the soul of the car has migrated from metal to silicon, if the feel of a BMW or a Porsche can be replicated by a download on a BYD, what does that mean for the brands we grew up loving? Are they just badges now?
That is the multi-billion-dollar question.
Thanks for diving deep with us today. Check your suspension, and we'll see you on the next one.